Alright, this video is going to start us talking about periodic functions. In particular, we're going to start off with the sine wave and the cosine wave, and these periodic functions are going to start off with a little bit of alpha, which the book uses the letter A for amplitude. Then we have the trigonometric function, and in this video we're only going to be talking about sine and cosine. Here, the omega in front of x is going to affect the period, and the book is going to use a capital letter B for this. Then we're going to subtract phi, and phi is going to be used by the book with the capital letter C. And this video is not going to talk about phase shifting or the horizontal shifting. That seems to be probably one of the more challenging transformations that we can do to these periodic functions, so we're going to keep that for last. And also this letter beta. This letter beta is used in the book by the letter D, and that is going to be our vertical shifting. So what we have to do in this unit is we're going to draw sine and cosine waves, and we're also going to do all the other trigonometric functions in later videos, and we're going to deal with amplitude, effects on the period, effects on the horizontal shift or phase shifting, and also vertical shifting as well. But we first kind of just need to break down what is a sine wave and what's some of the important vocabulary we're going to be using when talking about these waves. Well, the first thing we need to do is we need to talk about a period. A period is the span between the start and to where the point in the wave repeats itself. Now we're going to start at the origin for sine, and we're going to go from here to this moment. This is one period around a sine wave. And how this is created, it's created from the unit circle. Now think of the radius of a unit circle. The radius of the circle goes from 1 to -1. Now if you want to get out your unit circle chart that you made in the last unit, this is going to be incredibly useful to you because it'll help you kind of plot the points on the sine wave in the correct place and position. So you'll notice that if we're looking at the y value at 0 degrees, it is 0. The y value is 0. But if we go to 90 degrees, or pi over 2, you'll notice that the y value is 1. If we go to pi, or 180 degrees, then you'll notice that the y value is back to 0 again. But if we go to 3 pi over 2, which is also 270 degrees, then you'll notice that y is equal to -1. And then finally at 2 pi, the y value is back to 0. So this movement, this wave movement from 0 to 2 pi mimics the value of y as we go around the unit circle. Please search out cool videos that people have made with animated unit circles where a dot travels around in 360 degrees or 2 pi, and you get to see how it draws the sine wave. I don't want to go to some of those because they have copyright to them. I am just heralding you to go there because you've got some pretty cool animations. So this is one period of the unit circle. Then the second period would be from the 2 pi and would continue on. Now since my x scale is in pi over 2, I can count by pi over 2's. This is pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. This is 5 pi over 2. This would be 6 pi over 2, which is the same as 3 pi, 7 pi over 2, and then 8 pi over 2, which again would be 4 pi. So this gives you an example of 2 periods of the sine wave if we go from the dot to this dot at 2 pi and this dot at 4 pi. You are going to have to draw 2 periods of your sine wave when you do your paper pencil work. Now the cosine starts again at 0, but in this case the x value is at 1. Because again, if you look at the unit circle, the cosine value at 0 degrees is 1 because that's the x value at that. But if we go to pi over 2 at 90 degrees, you'll notice that we are at 0 on my x value. I probably shouldn't have the dot there because I'm going to use that dot for my period length. Okay, so if we go all the way to pi, or 180 degrees, now we're facing west, and that on the x value is -1. So you see we're down here at -1. Then we go to 3 pi over 2, which is 270 degrees, when we're back to where x is 0. And then at 2 pi, x is back to 1 again. So these tops of the peaks here are like this little smile from dot to dot represents one period of a cosine function. And that means the second period would be way over here at 4 pi. And we can just replicate this scale since we're not actually changing. So this is 3 pi and 7 pi over 2. Okay, so for each graph, mark the intercepts and coordinate points for each maximum and minimum. Well, we kind of did that up here. We actually marked the x values along the x scale. So what we could do is we could just make a nice little list or table for our points here if we'd like to. This would be kind of nice. So here we have our, so we have 0, pi over 2, pi, 3 pi over 2, and 2 pi. So from here, let's go to our second period, which is going to be 5 pi over 2, 6 pi would be 3 pi, 7 pi over 2, and then 8 pi over 2 would be 4 pi. So what we have is a sine wave here. So sine is going to be this column here, and cosine is going to be this column here. So we're going to start off with 0, and then we're going to go from 0 to 1, and then back to 0 again, -1, and then back to 0. So medium high, medium low, medium. You can see how it kind of makes that beautiful sine swoop. And then we're going to repeat it again from medium high, medium low, medium. Now for cosine, we're going to start off high, and it goes high, medium, low, medium, high. So it kind of like swoops like a smile. And then high, medium, low, medium, high. And you can write each of these like coordinates. You could put just parentheses and a comma between the two of them. And that's how you can make that work. Now let's talk about domain and range. The domain, if we look from the most left to the most, and first of all, I should say just right away, the domain and range of sine and cosine are the same. You can see that both of them are oscillating waves from -infinity to +infinity on the x, and they have a limit of 1 and -1 on the y. So for the domain, the interval notation would be -infinity to +infinity. And in set notation, we can make it really fancy if we want to, or we just say the set of all real numbers. I think we've seen some set notations that have said set notation x/x belonging to real, and then ending set notation, but we're going to be just a little bit more efficient with that. Now the range is not all real numbers, and it's not -infinity to infinity, because the height of the sine and cosine waves goes to 1, and the lowest part goes to -1. So that gives me a bracket from -1 to 1. And if we were to write this as a set notation, we would have our set notation y knocking on the door, which is y belonging to the set between -1 and 1, inclusively. Because we're going to include that 1 and -1, because you can see from our table here, we do actually land on 1s and -1s. And that's where we're going to end this video. Stay tuned for the next video where we look at amplitudes of sine and cosine.